Thank you for joining us for this DDI CADcast. Today's topic is What's New 2014, SOLIDWORKS Flow Simulation. The first topic I want to talk about is the fact that we can now take ECAD files imported from SolidWorks and bring our customer thermal properties directly into our flow simulation product. Let's take a look at this particular import we have at SolidWorks. Once I have it inside of our product, I can click on Properties, and I can take a look at any component, in this case this integrated circuit. And you'll notice under Properties we have several new properties that we can import directly into Flow. These are material density, material specific heat, conductivity, and conductivity for volumetric heat sources from components. When you finish importing this model into SolidWorks, you can then create a new flow simulation project, and we can actually import all solid material definitions, heat sources, and PCB information from the ECAD file. To do this, we go to Flow Simulation, Tools, and choose Import Data from Model. Once you review all of the data to be imported, we can choose the import icon, and SolidWorks will go ahead and generate all the different constraints that would have been done manually in your project. Once you're done with the import, you may now close the bottom tab and continue setting up your project. So in summation, this brings 3 items into your constraints. It brings in the solid materials definitions, your volumetric heat sources, and if you had any PCB information, this will generate new information for your engineering database. Let's take a look at the completed results to showcase a new item that's new with 2014. In Flow Simulation 2014, we can now export multiple flow simulation plots on a single eDrawings file. Let's take a look and show a couple of different plots. And to export this data to eDrawings, we're going to do a right-click on the Results folder and choose Save Image. At this point, we get to specify eDrawings from the pull-down. We're going to click the Save icon. And Flow Simulation will create this eDrawings file in the same directory as the saved file. In eDrawings, now we can continue to interrogate our results. Let's go in and hide all of our components to focus on the results. Let's move on now from eDrawings and talk more about the mesh inside of Flow Simulation for 2014. Flow Simulation has had the ability to do something called solution adaptive meshing, and for 2014 it has now extended this ability to include local or specific areas or regions inside of your flow computational domain. You'll notice here we start off with a local initial mesh, and to make sure that this area gets refined during the computation, we can right-click on Input Data, access Calculation Control Options, and under the Refinement tab, you're going to notice there's a new section for local regions where we can specify refinement settings. The other item related to meshing that we want to touch on is the fact that SOLIDWORKS reports that it speeds up our meshing task by using multiple cores. When we go in and we run our projects, the CPU and memory usage pull-down, allowing you to choose multiple cores, now affects the actual mesh of the project. Previously, you were only limited to 1 core in calculating the mesh for your project. The number of cores chosen affects both your mesh and your solver, so we cannot segregate and choose 2 cores for just the mesh and then 8 cores for the solver. It's all done in the one pull down. Lastly, this is also available for the batch run dialog boxes. Moving along, let's talk about parametric studies. Once we generate a new parametric study, whether it be an optimization or a what-if scenario, SOLIDWORKS will automatically generate a new entry for your parametric study under your project. This improves flexibility with the tool. Instead of having to save and reopen our setup, that setup now exists within our project and can be accessed later on. You'll notice our input variables, output parameters, and even our scenario information has been retained. An additional behavior that's new in 2014 is after you've run all of your different design points, Flow Simulation does not create separate configurations for each design point like in previous releases. Flow will simply add them to our Scenarios tab, and if that particular design point happens to be one of interest, I can choose to save that individual design point as a separate project. And that's what's new with Parametric Studies in 2014. Lastly, let's talk about some usability improvements that will really make a difference in how you approach your setups with Flow Simulation. The first item is Leak Tracker. Leak Tracker allows you to troubleshoot your projects for any open holes or displacement gaps in your model. In 2014, it has been moved and now has its own place within the interface. It appears on your lower left-hand corner as a new temporary tab. Another usability enhancement is that you can now modify your boundary and heat source conditions from one single property manager. For example, if I take 2 surface heat sources, I can use Control Select or Shift Select to grab multiple constraints and do a group edit. If you select constraints that are different, when you edit the definition of all the constraints, you'll notice that the heat generation will read different, and then you can always override the previous 3 volume sources. Some other improvements have been done in the area of goals. In 2013 and previous releases, before creating an equation goal, one needed to go in and generate a point surface or volume goal, and then generate an equation goal. In 2014, that is no longer the case. You can specify surface areas and volumes with our equations goal property manager as well. This last usability improvement is used for external analyses only. Under initial and ambient conditions, we now have the ability to specify the velocity globally using aerodynamic angles. To do this, we simply go into our initial ambient conditions for an external analysis, and under the Defined By section, we hit the pull down and we choose aerodynamic angles. This will allow us to enter a magnitude for the velocity, references for the longitudinal plane, and the longitudinal axis. This hopefully will make it easier to specify these global velocity magnitudes in the future. So that sums up our 2014 What's New SOLIDWORKS Flow Simulation CADcast. For more CADcast topics, please check out our YouTube channel at youtube.com/ddicad or our tech blog at ddicad.com/tech center. Thanks for watching.